Okay, so in this next video we're going to do two examples. It's blatantly obvious here. Our objective, what do we want to do with all of these problems, with the examples that we've seen in the past? We need to get a common denominator for the expression and then just work with the numerator. Makes life a lot easier. So we'll do two examples here. Once again, with all of these videos, you know, if you understand what's happening here, I would go ahead and try and solve without watching the video. So what I mean by that is saying, you know, pause it, try and solve it, and check your work. So as we see here, we have a couple different factors. We have the 2 in the denominator here, the x in the denominator here, and the 2x here. And so the idea is we want to have a 2x in the denominator for all. So this one we don't need to manipulate, but the 2 on the left side of the equal sign we have to. So the basic idea is, okay, what do we need to multiply this by in order to get it to be 2x? So we multiply this fraction by x over x. And we're going to multiply this one by 2 over 2. And so we're going to go ahead and work with each individual fraction. The first term is going to turn into 3x over 2x minus 6 over 2x is equal to 9 over 2x. And now that everything is common in the denominator, I just look at the numerators and I'm going to solve 3x minus 6 is equal to 9. Makes it a much more simpler problem to solve. So I add 6 to both sides, that's equal to 15. X is equal to 5. I look at my original problem, and if 5 was in the denominator, there's no issues. So x equals 5. In order for the equality to work, x has got to be 5. And there we go. Now we're going to move to another one, a little bit more going on. So as you can see here, a lot more complex. And one of the things that we need to do is we need to determine what the factors are. So if we notice the numerator here on the left side of the equal sign is just x minus 3. This one's just x. This is an x squared minus 3x. So you might be able to see exactly what needs to be done here. Some of you will be quick to just understand what you need to multiply both by. But a good rule of thumb is to rewrite our fractions with the denominators in factored form, because then what that tells us is we have to have an x and an x minus 3. That's the common denominator. So I'm going to multiply this guy by x over x, and I'm going to multiply the 3 over x, this guy right here, by x minus 3 over x minus 3. We can rewrite this, which I'm going to do, which means we have x times x plus 1 all over x times x minus 3 is equal to x minus 3 times x all over x minus 3. Made a little mistake here. This should be a 3 all over x plus, and then this one didn't change. You could technically skip this step and just go with what you have at the top. I'm writing it out for instructional purposes so we see that everything has a common denominator. Order doesn't matter in the bottom because it's multiplication. So even though some of these are out of order or not in the same order as the other, it's fine. So now I'm going to focus just on the numerator, and I'm going to set that up as a separate problem. So I'll do this in the top right-hand side. So I have x times x plus 1 is equal to x minus 3 times 3 plus 12. I'm going to distribute, so I get x squared plus x is equal to 3x minus 9 plus 12. And we're going to see that we end up with a quadratic. So I'm going to go just through each step. I'm going to combine these two guys, so I get a 3x plus 3. And I'm going to balance it out. So I'd get x squared, subtracting the 3x and the negative 3 from this side to the left. I'm going to get a Negative 2x minus 3 is equal to 0. And now I need to solve for x. So I'm going to, what two numbers multiply to negative 3, but add to negative 2. That's an x minus 3, x plus 1. So my solutions are x is equal to 3 or x is equal to negative 1. Now I need to look at my solutions and my denominators. I'm going to look at all of these guys right here. So will negative 1 work? So if I plug in negative 1 for x, I will end up with a number other than 0 in the denominator. If I plug in this 3, this guy right here is going to be 0. I cannot have 0 in the denominator, so I throw this guy out. It's a solution that will not work. So my only answer here is x is equal to negative 1. So once again, the idea is get a common denominator and just work with the numerator and solve for x.